All right, guys, lesson 18, permutations and combinations. If you've ever wondered how Sonic has so many drink combinations that they list on their menus, this is how we do it. How many different drinks are there? How many different candies? How many different flavors? And so on and so forth. And you just multiply them all together. That's how you get your number. All right. So there are some elementary techniques that you can use to count very efficiently. We will talk about all three of them. The product, which is what we just talked about with Sonic drinks, permutations, and combinations. So with the product, you just multiply. You're buying a frozen yogurt. Yogurt store has 3 different types of cones, 6 different flavors, and 8 kinds of toppings. So 3 times 6 times 8. Multiply them all together. How many can you buy? It'll be 144 different ways you can order your frozen yogurt. All right, now, permutations and combinations. There's different ways to do this. And you can see up here, there's formulas. NPR or N choose R for permutations, N choose R for combinations. And the formulas vary slightly. But you have factorials, which is what that exclamation point stands for. So multiply in a specific order. So order matters with permutations, order does not matter with combinations. And that's why the formulas differ a little bit. So there are 3 students, Alex, Bonnie, and Charles, lined up in a single file line. How many different ways can you line them up? Well, nobody's there. So there's 3 choices for the first spot, 2 choices for the second spot, and 1 choice for the second. When I multiply these 3 numbers together, that is 3 factorial, which is 6. So if I have a string of numbers, like let's say 5 factorial is 5 times 4 times 3 times 2 times 1. You multiply them all together, you get an answer. So when you do that, that's your factorial. So there are 6 ways to do. There's 6 ways to do that. Now, there's 9 students. They all get a ticket. So there's 9 for the first ticket, 8 for the second ticket, so on, and you work your way down. 9 factorial. That's 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And when you put that in your calculator, you get 362,800. 880. All right. So if all the spots are used, there's no sense in using the formula. You can just use the factorial. But like on number 4, students, 4 students in a club are interested in 2 positions. So now we have to choose. We don't get to use all 4. So this is going to be an example of 4P2. We got 4 positions. We're choosing 2. All right, and order matters. So president, vice president, how many ways can students be chosen for the 2 positions? So using the formula, I have 4 factorial over 4 minus 2 factorial. All right, so that's 4 factorial over 2 factorial. And if I break that out, that's going to be 4 times 3 times 2 times 1 over 2 times 1. So I can get rid of what they have in common. They have 2 and 1, so this is simply 4 times 3, which is 12. Now, I think the formula is cumbersome. I don't think it really, as long as the numbers don't get too big, I think you can handle it without the formula, especially if you're just using factorials. That's all this is. Like you have vice president and president, or president, vice president. The 2 positions, 4 people are choosing. I have 4 people to choose from for the first one. I have 3 people left to choose for the second one. 4 times 3 is 12. Like the formula just makes things a little more complicated sometimes. And so, but that's that. On number 5, you have 5 cars and 3 parking spaces. So 3 parking spaces. You have 5 cars that can fit the first 3. In the first one, after it's parked, you have 4. After it's parked, you have 3. So 5 times 4 times 3, multiply them up. 5 times 4 is 20, times 3 is 60. There's 60 ways you can park those cars. They don't necessarily use the formula all the time. All right, combinations. An arrangement of a certain number of items in which order does not matter. Okay, so there are just 2 parking spaces, but 4 cars, red, blue, yellow, and green. And how many different ways can 2 cars be parked? Order doesn't matter. Okay, so this would be using the formula 4 choose 2. And what this does is it gets rid of any overlaps. So on that first problem we talked Alex, Bonnie, and Charles, we could have said ABC. We could have also said CBA or something like that. Order doesn't matter. So these two would be the same. Okay, so when in permutations those are different, but in combinations those are the same. So order doesn't matter. So we're actually going to have less here. So 4 factorial is in the formula. This is going to be 2 factorial. So let me rewrite the formula. So we got n factorial over r factorial times n minus r factorial. So that's going to be 4 factorial over 2 factorial, 4 minus 2 factorial. So it's going to be 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. Okay, so you can get rid of some stuff and get rid of these two. So that would give you 12 over 2, which is 6. 2 parking spaces, but 4 cars. There's 6 ways you could do that. Red, blue, yellow, and green. There's 6 ways you can do that because order doesn't matter. All right. There are 3 job openings for a level 1 computer technician, 6 applicants. How many different ways could these 6 applicants be chosen for the 3 jobs? So this would be 6 choose 3. All right, so we've already done the formula. This is going to be 6 factorial over 3 factorial. 6 minus 3 is 3, so 3 factorial. So it's going to be 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 3 times 2 times 1. All right, so I can get rid of the 1s, 2s, and 3s, and then 3 times 2 is 6, so 5 times 4 is 20. All right, so you almost have to use the formula for combinations. The formula is not necessary for permutations. All right, so that's an example of each. Now we're going to practice all of these. All right, for number 8, how many different ways are there to place 5 books on 5 different shelves? Well, so 1, 2, 3, 4, 5. I can 5 ways to choose the first book, 4 ways to choose the second, 3, 2, 1. That's 5 factorial, which is 120. Okay. Andy has 7 shirts, 6 pants, 8 ties. How many different outfits can he make? So that's just straight multiplication. 7 times 6 times 8. And that's going to give you 336 outfit options. Number 10, there are 4 coach seats left on an airplane. 7 people are waiting for these. How many different ways can you use to choose 4 people? All right, so this is a combination. So 7 choose 4, 7 C 4. All right, so I got 7 factorial, 4 factorial, 3 factorial. All right, so you got 7 times 5 times 4 times 3 times 2 times 1. Oops, I forgot the 6. Times 6 times 5 times 4 times 3 times 2 times 1. All right, 4 times 3 times 2 times 1 times 3 times 2 times 1. All right, and get rid of these. 4 goes away. 3 and 2 is 6. All right, so 7 times 5 is 35. 35 ways to choose 4 people out of 7. All right, there are 4 people running for 4 different positions. All right, so all of them are going to be filled from the 4 people, so that's simply 4 factorial. So 4 times 3 times 2 times 1, that's simply going to be 24. All right, for breakfast, Jane has cereal, orange juice, an apple, and a piece of toast. Jane keeps 4 different types of cereal, 2 different kinds of orange juice, 3 different kinds of apples, 2 different kinds of breads. How many choices can she get? So that's simple multiplication. 4 times 2 times 3 times 2. All right, 8 times 6 is 48. All right, 13. There are 6 puppies born, but the mother always feeds only 4 puppies at a time. How many different ways can you do this? So you're choosing. All right, that's a combination. 6, order doesn't matter. So 6, choose 4. So that's going to be 6 factorial over 4 factorial times 2 factorial. So it's 6 times 5 times 4 times 3 times 2 times 1. 4 times 3 times 2 times 1 times 2 times 1. All right. 4s go away, 3s, 2s, 1s, and then 2. That leaves me with 30 over 2, which is 15. Okay. 14. There are 5 windows in a room. Rich bought 5 different curtains to go on there. How many different ways? So they're all going to be used. So that's 5 factorial. So 5 times 4 times 3 times 2 times 1. That's going to be 120 different ways he can lay out those curtains. Steve knows 5 notes on a guitar and plays 4 notes in a row. How many different ways? So this is 5. How many different ways will Steve be able to arrange his notes? So 4 notes in a row. He knows 5 notes. He can play any of the 5 anytime. So 5 times 5 times 5, that's 5 to the 4th, which is 625. Okay, 16. There are 9 different things to drink in Lisa's house, but Lisa only has 3 glasses. How many different ways are there to put 3 different drinks in the glasses? You can only put 1 type of drink in each glass. Okay, so order matters. Is what that last part is saying. You can only put 1 type of each drink. So once you've used that drink, you can't use it again. All right, so you have 9 choices for the first one, 8 choices for the second, 7 choices for the third. Simple multiplication, you get 504. Okay. A 7-digit phone number uses all the digits from 3 to 9. How many different possible phone numbers are there? Okay. So if you count on your hands, 3, 4, 5, 6, 7, 8, 9. That's 7 choices. 7 numbers. So he can use, how many different possible ways can you do that? So 7 factorial. So that's going to give you 5,040. So is it straight multiplication? Like, can I get there just by multiplying? Is it a permutation where order matters? And is it a straight factorial, or do I need to cut some numbers off? If you need to know which numbers to cut off, use the formula. But if you can figure it out without it, you don't have to use the formula. For combinations, order doesn't matter, and you need to use the formula. Okay, so for 18, this is our last one. This is a little more advanced. Given a class of 12 girls and 10 boys, answer each of the following. In how many ways can a committee of 5 consist of 3 girls and 2 boys? So there's 2 different scenarios we got. First of all, we have 12 girls, and we want to choose 3. And then we have 10 boys, and we want to choose 2. Okay, and notice I'm going to multiply these 2 together. So this is my girls, this is my boys. All right, so normally this would be 12 factorial over 3 factorial times 9 factorial. Well, the 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And I can take all of that string of numbers out of the top and just leave me with 12 times 11 times 10, which would leave me with 3 factorial on the bottom. So this is what I have for the first, for the girls. For the boys, I can do the same thing. This would be 10 times 9 over 2 times 1. Okay, so this is saying I can get rid of some stuff. I can reduce 3 and 2 is 6, and that goes into 12 2 times. 2 goes into 10 5 times. Okay, so that's going to leave me with 220 times 45, which is 9,900. Okay, so for A, there are 9,900 ways those can be chosen. Now for B, it says how many ways can you choose 5 communities of 5 and have no boys. So in this situation, I still have 12 girls, but I'm choosing 5. And for the boys, you have 10 and you're choosing none of them. Okay, well, so here's how you think about it. You got 12 times 11 times 10 times 9 times 8 over 5 times 4 times 3 times 2 times 1. Okay, so, and then there's only one way you could choose none. So times 1. All right, well, all right, 5 and 2 go into 10. 4 and 3 go into 12. So that leaves me with 11 times 9 times 8, which is going to give me 792. So if I leave out the boys, there are 792 ways to choose a committee of 5 from the 12 girls. Right? All right, so just to recap real quick, you know that 12 choose 3, if I use the formula, is 12 factorial over 3 factorial, 9 factorial. Well, if I list all this out, that's going to be 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All right, well, 3 factorial is 3 times 2 times 1. 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Well, I can get rid of all this because 9 factorial. So that leaves me with this piece, which is what I have right here. Okay, so you can do that. How many things am I choosing? Like while I go on B, I had 5, I was choosing 5. So I picked the first 5 digits and then cut off the rest. So 12, 11, 9, 12, 11, 10, 9, and 8, and then I put 5 factorial underneath. So that is a cleaned up version of the formula instead of writing all those numbers. And especially as numbers get a little bigger than what we've been dealing with here, that might be really helpful for you. That's lesson 18. We got one left. Reach out if you have any questions, and I'll see you in the next lesson.